The constant demand for energy is proving a challenge in those parts of the world where electricity grid infrastructure is often insufficient to meet energy needs. These are conditions that force industries, farms and in general areas of productive life to significant economic efforts. Not rarely, the most complex requests occur in areas where electricity grids are poorly organized or absent. This condition forces businesses to use diesel generators to ensure the production of energy. A solution that has, however, considerable costs, determined by the price of fuel and transportation to places of work. Because of these two variable parameters, the price of the energy produced by the diesel generators is destined to increase constantly over time. An effective and long-lasting alternative is represented by the photovoltaic systems, real sources of productivity, especially in very sunny regions. The use of photovoltaic technology in combination with diesel generators determines significant cost savings, ensuring a constant productivity. A photovoltaic system directly converts solar energy into electricity. It consists essentially of photovoltaic panels, inverters, which convert the direct current generated by the panels into alternating current, the electrical panels, and the connecting cables. Not being able to program the availability of solar radiation, the proportion of power that can be fed into the network powered with diesel generators is roughly limited to 20%. To increase the power of the photovoltaic plant, lowering the fuel consumption threshold, an intelligent communication is needed between the inverters and the diesel generators. Cappello Group, thanks to the PV hybrid system, is able to better integrate the photovoltaic systems with the plants powered by diesel generators. A solution that allows an incidence of the photovoltaic up to 60%, optimizing the stability of the electricity grid. The hybrid PV system installed by Cappello Group synchronizes the photovoltaic system with the diesel generators. All the information is elaborated by the controller, which analyzes the data with the requests of the loads from the company, the characteristics of the electricity grid, and any other necessary parameter establishing the ideal operating point of the photovoltaic system. The PV hybrid system is thus able to meet the dynamic demands of the electricity grid. In case fast load decreases occur, the PV hybrid system acts instantaneously, reducing the photovoltaic power to maintain the optimal operation of the generators, with a consequent stability of the electricity grid. When loads which engage the network quickly are used, PV hybrid reacts to changes with absolute flexibility. Even when the photovoltaic production decreases because of a cloudy sky, the stability of the grid is always guaranteed. The controller also has the possibility to constantly monitor the generator reserve. During sunny days, the PV hybrid controller limits to the minimum the production of the diesel generator, with a consequent reduction of costs. In the evening hours, the function of the generator increases its supply of energy, taking on the burden of consumption in progress. There is also the possibility to use the energy produced by the photovoltaic in the night hours. In this case, it is sufficient to integrate the system with a storage unit able to operate in support of the diesel generator. In the case that in the location of the system installation, a stable electricity grid were present, The photovoltaic would assume the function of reducing daily consumption and providing free and clean energy. The generation of energy by the photovoltaic system follows the request by the loads. If the photovoltaic generates all the energy required by the loads, the absorption from the grid is null. In the event the photovoltaic system is not generating all the energy required by the loads, for example because the day is cloudy, the missing energy is absorbed from the grid. Obviously, the system is able to follow dynamically the absorption of loads by giving priority to the photovoltaic. During the night, all the energy required by the loads is provided by the grid. In a configuration of this type, the diesel generator has only a backup feature and comes into operation only in case the grid is unavailable and at the same time the photovoltaic is not producing, for example during night hours in the event of a grid disconnection. In the case where the photovoltaic system is producing a greater quantity of energy than that required by the loads, the excess energy can be used to load an optional battery pack, or it can be fed into the grid if allowed. In case there is a battery pack, during the night all the energy required by the loads is supplied by the batteries. If the energy stored in the batteries is not enough to meet the entire demand of the loads, the additional energy required is absorbed from the grid. The benefits are various: significant reduction in the cost of electricity, ability to meet the needs of loads in real time, adapting to the needs of each client, lower risk for power generation costs, relying on the increase in oil prices, using a system designed to work in extreme environments. PV hybrid is the ideal solution for the perfect integration between systems powered by fossil fuels and the energies of the future.